Look at the sine rule, and we're going to do the sine rule and the proof of the sine rule, and then look at the area of a triangle as well using your kind of trig rule, I suppose. So we're going to look at those three things for today. So first of all, going over the sine rule, so we know how to use the trig ratios when we're finding our sides or our angles. So we can use our sine, our cos, and our tan, like our SOHCAHTOA. But what we want to look at now is how to find rules that can be used with any triangle. So the sine rule is the first rule that we can use with any triangle. So it can be used with right angle, but it can also be used with any triangle at all. And that's really more where we might end up using it. So the sine rule is the rule you can see here. So A over sine A is equal to B over sine B is equal to C over sine C. And within that rule, we have that maybe this side A here is related, is the one opposite angle A. Okay, and similarly, side B is opposite angle B. The way that it's written here is the way that it's written in the log tables. So that's the way that you would see in an exam. So it's important that you're just kind of used to the way that it's formatted there, but also that you just know that all that it means is that if you're putting in something in place of side B, what goes on the bottom of the fraction should be the angle that's opposite it and sine of that angle. Okay, so even if the letters are different, or if A and B and C and all of those are all mixed up, just keeping it that you know that each fraction is made up of the side and the angle that's opposite it. And we can also have the sine rule written on the opposite way around, so flipping everything upside down. And generally where that comes in useful is if we're looking for the angle, it's sometimes just easier for us to rewrite the formula so that all the angles are on top. And if we're looking for the side, then we can use the formula where all the sides are on top. Okay, it just makes it easier. We can also see the rule has three parts. We only need to use two. Okay, we never really do a sum that has three equal signs, but we do sums obviously that have, or two equal signs, but we'll do sums with obviously one equal sign. So to use the sine rule, we must have either two sides and one angle. Okay, so either two sides and one angle or two angles and one side. So we can see from the formula, if I kind of just look at this example here, we generally just use two parts. So say we're using this part here with the sine A and the sine B. We need to have, if we're looking for one part of this, so say we were looking for angle B here. Okay, this is what we want. Then what we need to have is we need to have side B, side A, and angle A. So we need to have two other sides and an angle to find the remaining angle. So there's four parts, so two angles, two sides, and we need to have three of them. So let's see how it looks in terms of an example. So in the triangle ABC, side AB is 8 centimeters, side BAC or angle BAC is 30 degrees, and angle BCA is 40 degrees. Find side BC. So the best way to start these sort of questions is to just draw a quick sketch. Obviously, the sketch doesn't have to be entirely accurate at all, but it's just to give us a sense of what we're looking at, and it helps us maybe label sides and things like that. So AB is 8 centimeters, which is here. Angle BAC is 30 degrees, which is here. And then angle BCA is 40 degrees, which is here. And we are looking for side, let me see, I'll get my blue. We are looking for side BC, which is this side here. Okay, so we want to find this side here. So if we were to kind of label it in terms of our sine rule, I suppose, we might call this side A an angle A opposite, it's side B an angle B, and then side C an angle C. So in terms of my sine rule, I'm going to be doing, I'm looking for A. So A over sine A is equal to, and we can say C over sine C. The letters don't make an awful lot of difference in terms of how we're going to do the question, so long as we just have, as we said, that side matched up with the angle that's opposite it. So looking for side A, sine of 30 is equal to 8 over sine of 40. Okay, so A is 8 sine 30 over sine 40, and we can put that into our calculator to find out what that side A is. And we could also have just used the notation BC that they gave us in the question. That would be obviously fine as well. So then just getting that using our calculator, we get an answer of 6.22 centimeters. So the length of BC is 6.22 centimeters. Okay. So that's the first part there. So you can see fairly straightforward, just a matter of definitely filling in everything where it's supposed to go. So matching up your sides and your angles the whole time, and then just following it through. We look at another example then. So this might be more typical of a kind of exam question, giving a bit more real life context to it. So an exit sign is suspended from the ceiling of a concert venue by two chains. One chain is 46 centimeters long and makes an angle of 60 degrees with the ceiling. The other chain is 64 centimeters long. What angle does the longer chain make with the ceiling? Answer correct to one decimal place. So let's try and figure out what this looks like. So the sign is suspended from the ceiling. So if we let this be the ceiling, okay, because I know from reading that I can't really tell what we're being asked exactly, but if we kind of make a sketch of it, it helps to make it clearer. So if we say this is my exit sign, so my exit sign is here, it's connected by two chains, so let's put one of the chains here and the other chain here. Okay, one chain is 46 centimeters long, so let's let that be this one, and makes an angle of 60 degrees with the ceiling, so that's your 60 degrees here. The other chain is 64 centimeters long, and what we want to find is this angle here that it makes with the ceiling. Okay, so the small angle that it makes with the ceiling. Okay, so looking at what we have, we're looking for the angle, so maybe we'll use the form of the formula that has the angles at the top. So sine A over A is equal to sine B over B. We can fill in, so if I take maybe angle A as the one that I'm looking for, so maybe say sine theta over 46 is sine 60 over 64. So again, just matching everything up. So we're matching this angle up with this side, and then this angle up with this side. Okay, just keeping everything consistent. So if I take this up here, sine theta is 46 sine 60 over 64. And we get then that sine theta is equal to, so let's just put that into our calculator then, 46 sine 60 divided by 64. And we get 23 root 3 over 64. Now what we have to be careful of here, and we would have seen when we did our trig equations, and it's something we'll look at maybe in the next little part, is whether we can have two answers at this point. Because if we look at this example here, at this kind of how far we've gotten so far, this is obviously a trig equation where we're looking for an angle and we have the solution. We should know from our trig equations that, see, I'll just draw a sketch here. We should kind of know that for sine can be positive in this quadrant, but also in this quadrant here. So if I'm given an answer that's positive, like we have here, okay, because this is positive, if I'm given an answer that's positive here, then it's possible that there's more than one answer. So we might have to consider that for this question. So if we were to take the reference angle, okay, so if we're to take the reference angle using the inverse there, so we can take sine inverse of that answer to see what we get. And we get an answer of 38.496. Okay, we'll maybe round that to about 38 degrees. Okay, and if we were to kind of work out then what that leaves in terms of the other angle, that would be 180 minus 38, which gives me an answer of 142. And just doing this to the side, I suppose, for a particular reason, but if we do this here, so what I'm doing is I'm looking for this second angle, so this represented in the blue here. So what's the other angle that would work for this scenario, for this equation? And it's an angle of 142 degrees. Now we know if we're looking at a triangle, all of my angles should add up to 180. And if I have one angle that's 60 that I know for definite is 60, because we have that up here. So if I know one of my angles is 60, then if the other angle was 142, that means the two angles would have a total of 202, which is not possible. So all that means for us in this case is that there is only actually one solution. Okay, so there is actually only one solution. And we'll look at this in a little second. We'll just kind of go over maybe the example where there is two solutions and how would we kind of see the difference there. But going back to what we have here, so we have theta is 38 degrees, and that's the angle then that and to one decimal place, excuse me, so 38.5 degrees. And that's the angle that's made with the ceiling by the longer chain. Okay, so kind of building then on what we've seen in that last question is just looking at then what are the situations where maybe we do have two possible answers, and the name for that type of question is called the ambiguous case. So the ambiguous case is where we do a question with our sine rule and we result in a situation where we have a sine equation and there are two possible answers to that. So we have to then see what those two answers are and see whether they both work for the question that we have. And that will usually depend on the angles that we are given in the question already and whether the two angles that we find can work with that angle. So we saw that in the last question that even though we could find what the two angles were, it wasn't possible for the answer to be one of those angles. So if we look at this example here, we might just draw again a sketch of the triangle to just fill in the information that we have. So AB is 15.3, AC is 17.6, and BCA is 48. Okay, so first of all, maybe we'll try and find one of the angles. So angle B. So sine of B over B is sine of C over C. Sine of B over 17.6 is sine of 48 over 15.3. Sine of B is 17.6 sine 48 over 15.3. And so we get then that sine of B is equal to 0.855. Okay, so same point that we were kind of at with the last question. This is an example of a trig equation. And if we're unsure of kind of answering our trig equations, then that might be an opportunity to maybe look back at that video or look back over the notes on that. But to start answering our trig equation, we need to see, first of all, make a sketch of where sine is positive. Okay, so we already know from our kind of cast circle that sine is positive in the first quadrant, as they all are, and also the second quadrant. Now we need to find our reference angle. So my reference angle, we take the positive value of the question that we have, so the same as we have in the question. And to get my reference angle, I take the sine inverse, and I get an answer of 58.74 degrees. So that means that this angle here is 58.74, as is this angle here. What I want to find is this blue angle and the red angle. So the blue angle is the same as the reference angle, so 58.74. The red angle here is going to be 180 minus 58.74, which gives me 121.26. So my two options for angle B are that it's 58.74 or that it's 121.26. Sorry, angle B there. B. Okay. So let's check and see, does that make sense for the question that we have? So the only other angle we have in this question so far is the 48 degrees. If I add on 48 degrees to both of these triangles, or to both of these angles, do I still have an answer below 180 degrees? Because we know our triangle can only have a total of 180 degrees. Well, for the first one, I mean, we should be able to kind of tell from the answers that we have, but for the first sum we end up with an answer that's below even, that's just about over 100, so that's fine. For the second one, again, we do end up with an answer that is possible, 169.26 degrees. So where this leaves us then is at a point where we can work out the other angles. Let me just move this down. So we can work out the other angles. So if we do 180 minus 106.74, what do we get? Well, we get that the last remaining angle in the triangle must be 73.26, so that was angle C. And here, I'm doing 180 minus 169.26, which gives me an answer of 10. 58.74 degrees as my angle C. So what we have now are two options for this triangle. So we can have one option that's, fairly similar to what we had already. Okay, so where angle, or sorry, not angle C, it was actually angle A here. Let me correct that. So what we had originally was that this angle was 48 degrees. We worked out that angle B for this triangle was 58.74. And we've now worked out that angle A is 73.26. Okay, we also had the other sides, 15.3 and 17.6. Okay, so that's one of our triangles. The other triangle that we can have here is that angle A is a fair bit smaller than the other angles. Okay, so we have angle B being quite big and angle C still being the same size that it was. And with these sort of triangles, I suppose the main thing is just to fill in the information correctly. Whether your triangle ends up actually being accurate is another story. But trying to get 121 degrees as best we can. Now we're ending up there looking fairly similar on both sides. But again, it's just to get some sort of sense of what the triangle will look like. Okay, so if we kind of follow this along, so again, we know that C is 48 degrees. We know that B this time we're saying is 121.26 degrees, and C is 10.74 degrees. Okay, we still have then the sides the same, 15.3 and 17.6. So now to finish out the question, to find the last two remaining sides, obviously those are going to depend on the two angles that we have. So we can use our sine rule again. We're looking for this side here, which we can call side A on both triangles. So looking for side A. So sine, or we'll leave side A actually on the top. So A over sine A is equal to, and we can do either or, so we would do C over sine C. So A over sine 73.26 equals C. So 15.3 over sine 48. And so A is 15.3 multiplied by sine 73.26. And you can work out these answers as you go, but sometimes it's just easier to nearly leave it to the end and to input kind of the whole thing into your calculator. Just saves us some work and some rounding as we go. And we get an answer of 19.72. Okay, doing similar on the other triangle, we're just expecting to end up with a slightly different answer. Okay, that's the only, because all that we've changed is that angle. Okay, so that angle A is different this time. So we still have side A that we're looking for, but this time it's sine of 1074. Side C is still the same. And angle C is again still the same. So 15.3 sine 74. And so A is 15.3 sine 1074 divided by sine 48. And we get that A is 3.84. So we can see there quite different answers in terms of that side A. And just depending on how big that angle A is, I suppose, just has an impact then on the side. But that's an example of the ambiguous case. So we can see where it branched off was this point here, and it's usually, it will only come up where you're looking for angles, because obviously we end up with this trig equation here. So if we even just make a note. So we end up with this trig equation here. And because we have a trig equation, even though it's coming up in a different situation than we might expect it, we still have to be wary of it and still on the lookout for it and still kind of recognize it. But it's something to bear in mind that with sine you may have that ambiguous case, so just be aware of it and look for those kind of other sides of the answers then. Right, so we've used sine rule. Now we want to look at how do I prove the sine rule? How do I make sure that it's accurate? So if I'm proving the sine rule, what I want to prove is A over sine A is equal to B over sine B is equal to C over sine C. Okay, straightforward enough. So we have two cases we want to look at. So we have what we call the acute case and what we call the obtuse case. And this is looking back at what we did in the previous example. So we had that ambiguous case where we were looking for angle B, And we saw that angle B was either going to be an acute angle or could be an obtuse angle. So it could be greater than 90. And this is what we're accounting for here, that if we have a triangle, all my angles could be acute or one of them could be obtuse, and that's going to affect just how we prove the triangle. So the first step, we're given our triangles, we sketch these triangles in. Our construction is that we're going to draw BD perpendicular to AC. So you can see here, you're drawing that line BD, so you're putting in that point D and sketching a line that's going to be perpendicular to AC. So at 90 degrees. What we want to do now is we want to take each of our angles. Okay, we want to pick two of the angles. So we'll do A and C. We need to include that obtuse case, and we'll do A as well. So if I start with angle A here, if I get sine of A is going to be BD over which side? Well, I need to just label in my side. So if I call this side A, call this side C, and do the same over here. If I call this one side A of my triangle here, if I call this side C of my triangle here. Again, same as we've been doing, just the side opposite the angle. Then sine A will be BD over C, which of course I can rearrange to get the BD is C sine A. Okay, and that's my first equation like that. Okay, what I want to do then is maybe I look at angle C. Okay, so sine of C is going to again be BD, but this time over A. So I get that BD is A sine C, which again gives me two equations. So I get two equations that have BD, okay, two things for BD, so I can set those equal to each other. So that means that A sine C is equal to C sine A. And rearranging that, okay, dividing across by each side, I can get A sine A is equal to C over sine C. Okay, and then in a similar way, if we were to draw a perpendicular on the other side, so from C to AB, so if I was to sketch in this line here, I could prove the other equation, so I could prove it from my B over sine B also. Let's just see then about the obtuse case. Okay, so the other case here. Do we end up with the same thing here? So again, picking our angles. So we'll start with maybe angle A here. So if I want to get angle A, I need to get sine of A. Okay, so starting with that angle here, so sine of A is going to be BD over my side C. So again, I get the BD is C sine A. To get my other angle, to get sine C, what I have to be careful of is that I have C here. Okay, that's not actually the one that I want to work with. The one that I would like is this one here. Because with that one there, I get a nice right angled triangle here, where I have BD involved, and we know that I need to have BD and A. So we have to see what that angle is going to be, and that angle is actually 180 minus C. Okay, so my green angle here is 180 minus C, if C is my pink angle there. But what we should kind of know about looking at sine from before and from looking at our cast circle and that idea of our reference angles is that if I'm getting 180 minus C, so if we set it up in that same way, and I get sine of 180 minus C, what we should know is that that is actually the same as just getting sine of C. And why is that? Well, we need to think about our reference angles. So if we look at the previous one, because we had it drawn out nicely, in terms of getting sine of those equations, my two angles there, the red and blue, sine of each of those gives me the same answer. So following along, we can rearrange. I can get BD is equal to A sine C. And then I can again equate those two. So A sine C equals C sine A, and rearrange to get A over sine A equals C over sine C. Okay, just give myself a little bit more space here to work with. Oh, I've lost part of it. Lost it. Okay, sine A, sine C. Okay, then we add a little note. So similarly, by drawing perpendicular from C to AB, we can prove that A sine A is equal to B sine B. So we're making a note that if we were to draw that perpendicular line, we could prove this. But what it means is we don't have to. And therefore, we have then that A sine A is equal to B sine B is equal to C sine C. So that's our proof of the sine rule. It's really, really important that you're able to get that proof off, and it is produced, it's in your notes. So it's just one to kind of look over. I've run through it fairly quickly here, but that's just to kind of go through the key parts and maybe why are we doing certain things. The main one maybe to watch out for is this part here with the 180 minus C. So recognizing that that green angle here is actually 180 degrees minus angle C. But when I go to find sine of that part, I get that sine of 180 minus C is the same as sine of C. And that's kind of by treating that C nearly like our reference angle. The last little part in our kind of whistle-stop tour of the sine related rules is the area of a triangle. So if we're looking for the area of a triangle, we're used to using a half base by height. What we're going to look at is a slightly different rule, which is half AB sine C. And in terms of this formula, I've drawn kind of a little diagram here, and it's really important. So in your log tables, that is the way the rule will be given, AB sine C. Now where that relates to is this part of your triangle here. And what we should note is that we have two sides, A and B, and we have the angle between them, C. In order to use this formula, you need to have two sides and the angle between them. It does not necessarily have to be angle C if the angles have letters, so long as you have two sides and the angle between those two sides, then you can use this formula. Okay, so that's the key thing, two sides and the angle between them. So let's see how it looks. It's fairly straightforward. If we try it with this example here, so we need our two sides, so 20 and 24, it doesn't really matter which we say is A and B, and the angle between them. And then it's just a matter of plugging that into our calculator. We have 123.6, not degrees, sorry, 123.6, so units squared, whatever the units are. Looking then at the next part, again, two sides, angle between them. So we have half AB sine C. Okay, this time they've said the angle is called A. Doesn't really matter, we can write down the formula as it is, and we can fill in the different angle, and they've given us this time the answer. Okay, so they've said the answer is 12 centimeters squared. Find the measure of angle A. So if the answer is already 12 centimeters squared, we can do our 1 over 2 by 6 by 7, get 21, so I get 21 sine A is equal to 12. Then sine A is equal to 12 over 21. And to get my angle A, I can take the inverse. I get 34.85 degrees. Okay, and looking at the triangle that we have, that makes sense for the triangle that we've been given. Okay, it wouldn't make sense for us to work out the other case. We can have a look at it. We should kind of know at this point that to find the other case, we can just do 180 minus 34.85, and we'll get an answer of 145. But in terms of the triangle that we're looking at, 145 isn't logical. Okay, it doesn't make sense for the triangle that we have there because we've been given the diagram. Okay, if we weren't given the diagram and just given the information, then yes, we could have that option of that being the angle. So to the nearest degree, A is 35 degrees. Okay, so again, kind of flying through a lot of that there. But the key things with your area of a triangle formula is that we could rewrite that formula for any part of the triangle. So if we wanted to take it from here, it would become a half BC sine A. Or if we were to do it For this corner, it could be a half AC sine B. Okay, the letters are just kind of chosen to give you that idea of it being two sides, an angle between them. Okay, so that is the main thing with your area of a triangle. So key parts, I suppose, from this whole thing is area of a triangle, sine rule, making sure you're happy with your sine rule, that ambiguous case, which is something that just you need to watch out for and just see if there's an option of that. Sometimes it's maybe just the best thing to do is to find the two options and then maybe rule out the other one if need be. And then the proof of the sine rule, so making sure that you know that proof off correctly. So those are kind of your key things in terms of your sine rule and your sine related formula.